All right, today's lesson is going to be about figuring out the number of shells and the number of valence electrons from an element's location on the periodic table. Now, the first term that you're going to need to be familiar with is a period, and a period is the name for each row on the periodic table. You can see that the rows are different colors here, each of the periods, and the elements that are in the same period have the same number of valence electrons. So here, the red ones in the first period have one shell or one energy level. In the second, right here, the orange, all of those have two shells or two energy levels. Third, it has three energy levels, and the fourth period has four energy levels. And that pattern continues as you go down the periodic table. Now notice that these are the same color, the rare earth elements, as the last two periods on the periodic table because they're pulled out of this position right here. So it's going to be one energy level, 2, 3, 4, 5, 6, and 7. The groups are the columns that go up and down on the periodic table. They are also called families, and they have the same number of electrons in their outer energy level. And those outer electrons, as we know, are called valence electrons. So group 1 here has one outside electron. Group 2 has two valence electrons, and then the pattern continues. We skip the transition metals, and then we have 3, 4, 5, 6, 7 until we get to the very last column, the last group, which has 8 valence electrons. Now, helium is an exception. It is in this last group. It does not have 8 electrons. It only has 2, and we'll talk about that a little bit more later. The transition metals, remember the transition metals have slightly different rules for the number of shells and the number of valence electrons, so we're not going to get into that. We'll let your high school chemistry teacher teach you those. All right, let's do some practice. The first one, determine the number of shells and the number of valence electrons for carbon. Well, carbon, when you draw it out, looks like this. It's in the second period, which means it's in the second row, so it has two energy levels, 1, 2. It has 4 valence electrons because it's in the fourth group. Remember, skipping the transition metals, it has 1, 2, 3, 4 outside electrons. For sodium, sodium has 3 energy levels, 1, 2, 3, because it is in the third row, the third period, and it's in the first group, so it has only 1 valence electron. So hopefully you're getting the pattern. The row tells you the number of energy levels, the period, and the group or the column tells you the number of valence electrons. So let's give neon a try. Ne is neon. It has 2 shells, 2 energy levels because it's in the second period, and it has 8 valence electrons because it's in the 8th group. So here's a diagram of neon. You can see again it has 2 energy levels and it has 8 valence electrons. Okay, go ahead and pause this and give this one a try. On your sheet, fill out the name of the element, the shells, and the valence electrons. When you're done, go ahead and start the video back up so you can check your answer. This is hydrogen. Hydrogen is in the first row, the first period, so it has 1 energy level. It's in the first group, so it has 1 valence electron. Pause your video again. And you should have put that. Be stands for beryllium. Beryllium is found in the second period, the second row, so it has 2 shells. And it's in the second group, so it has 2 valence electrons. Once again, pause your video, see if you can figure out the name for S. You should have said that S is sulfur. Sulfur is found in the third period, so it has 3 energy levels. It's found in the 6th group, so it has 6 valence electrons. And here we can see our 3 energy levels and the 6 outside electrons. Now let's give K a try. Pause your video. You should have found that K is potassium. Potassium is in the 4th period, so it has 4 energy levels, and it's in the first group, so it has 1 valence electron. There's our 4 energy levels and our 1 valence electron. And then helium. Helium is a little bit different. Helium is in the first period, so it only has 1 shell. It's in the 8th group, but it actually only has 2 valence electrons. It doesn't completely fit the pattern, and the reason is because it's an exception. It's in group 8. It has only 1 shell, and the first shell can only hold 2 electrons instead of 8. However, it's still considered part of the 8th group, which are the noble gases, because when it has those 2 in the first shell, its energy level is full. And that's what makes the noble gases distinctive, is that they have an energy level, their very last one, that's full. And so helium behaves the same way because of that. All right, that's the end of your study guide. Make sure you have all your answers on your worksheet.